Hello everyone, I would like to thank you for being here. I must admit that today I want to talk about big data, data science, machine learning. Yesterday, together with my colleagues, Sebastian and Pavel, we did the Amazon SageMaker workshop about machine learning, CTRs, ad tech. But today I would like to present a different thing. We are getting closer and closer to the final keynote, and I will do my best to inspire you and show you a new cool stuff around the block called Serverless, and this new approach which is available in an IT landscape. And I will do this with a little bit of twist because it will be supported by the personal experience and supported by the evidence in the form of measurements and evaluation. And it will be from the perspective of a functional programmer because I am one as well. A little bit about me. From the most important things, I'm Gawroński over internet. On Twitter, Facebook, you will find me under this nickname. I'm also a co-founder of the Pattern Match. I'm a functional programmer on daily basis. I work mostly with Erlang and Elixir. I own 3 certificates in AWS, and most of the talk will be about AWS, but I will leave some references to other cloud providers as well. And I'm also a co-founder and co-organizer of the Functional Miners meetup in Poland. If you will be somewhere in Silesia, please visit us. In Pattern Match, we do all kinds of stuff, but mostly around AWS and consulting around cloud computing, scaling, and embracing the cloud computing to build the competitive advantage. So, before we will talk about the idea and we'll introduce serverless and talk more about it, I would like to know a little bit more about you. So how many of you are software engineers but not related with data science at all? Please raise your hand. Okay, there's a couple of people. How many of you are data scientists by heart and knowledge? And the rest of you, what is your job to do here? I hope that you will spend this time productively with me. Whole idea and the concept started more than a year ago when one of our clients wanted to do a proof of concept with us. And after intensive discussions, we started to wonder if we have other choices than JavaScript, Java, and C# in serverless world. And we wanted to leverage our functional programmers' experience in that area as well. I went into that rabbit hole, and it turned out that it was a very interesting way to learn. And I would like to present you a distilled version from the journey. For me, the main goal was to determine if I have to start a new serverless project and I would like to use a functional programming language, what tools and what frameworks will provide the most predictable, the most sane, and least effort experience for me as a programmer. So, before we will talk about details and technology, I would like to ask you about how many of you heard about serverless? Please raise your hand, okay? And how many of you are using it in the production right now? Okay, 2 hands. So, I hope that you'll enjoy this ride with me as well.
It depends on what you call production.
Exactly. That's another thing. For us, in that particular project, we started with a proof of concept, but then we moved to the production. But as you said, the definition of the production is very different for everyone. So most of you know a lot about serverless, or at least heard the term. But let's go and provide a common ground for everyone. First of all, I would like to complain about something. In my opinion, in computer science, we suck at naming things. And maybe you know this old joke, but there are 2 major problems in computer science. Cache invalidation, naming things, and off-by-1 errors. So basically, in my opinion, serverless, cloud computing, those terms are pretty noisy, and they are not providing enough information. And they are also simplifying the reality. The problem with serverless that I have is that many people are thinking that there are no servers. Of course they will be. I don't have to explain it on the technical conference, but still there are people that are believing that. At the end, we need to execute our code on the hardware. It will be someone else's hardware. Moreover, a couple of people started to derive another conclusions from that name, and they said that there is no operation people, administrators, sysadmins. That's also not true. Those people will be needed. Their responsibilities will shift and they will change, but definitely those people will be needed, even if we will talk about serverless and use serverless. For me, serverless is more like a transition from owning the infrastructure to consuming the infrastructure. The whole concept described as a serverless is a natural evolution that we are observing in IT world. So basically we started back in the days with the data center and physical hardware. We basically moved stuff from one place to another with physical things, racks, and so on. Then we moved to the virtualization with use of infrastructure as a service. Then we moved a step further and we abstracted the virtualization layer and started to building on top of the platforms. And at the end of that spectrum right now is serverless as a thing that we are basically consuming, and we are thinking in terms of our code, which will be deployed and scaled by someone else. One thing that is noticeable here is that if we go from the left to the right, we basically giving back something in exchange. So here we have the full flexibility, but full responsibilities as well. Here we have a lot of options, maybe less operational complexity, but still we have to give up something. I will return to that point later. When it comes to the serverless backends, there are two major flavors right now available on the market. One is called backend as a service, and if you ever used Firebase or Parse or any other service, you basically use that solution. It's an abstracted built product that can be leveraged by your company, by your products as well, which is tested and basically provides a very common stuff and tasks that we are doing on a daily basis. In my talk, I would like to focus on the function as a service solutions, which are represented by AWS Lambda, Google Cloud Functions, and Azure Functions. For those of you who have never heard the term function as a service, it's basically a way of running your code on demand on someone else's infrastructure with minimal operational hassle. That first word in that acronym, function, suggests that we as a functional programmers should be in the privileged situation, and that's not true. I will address that later. One key thing here is that this serverless and this split, those two flavors, are basically representatives of just the spectrum for the backend. There's whole new branch related with software as a service solutions, which can be represented by Amazon Athena, Google BigQuery, and other services that are consumable as a serverless platforms, more like, and doing other stuff than backend services. Just keep that in mind. I'm talking here about backend services, because we will talk later about functional programming languages and how to build the backend with use of those languages. One word about how it works and what is the billing. So at the beginning, we basically create our source code and prepare a package from that source code. Then we attach some kind of configuration for our cloud provider, and basically that's it. We need to upload the configuration and the package to a cloud provider, and someone else will host that for us on their infrastructure. They will manage deployment, they will manage scaling it up, scaling it down, everything seamlessly with promise of infinite scalability. As I said, everything is done on the provider side, and that influences the billing and pricing. So in that example for Lambda, we are paying for two things. One is the amount of incoming events that are going to our code and will invoke it. We are paying for batches of million events, And in our case, currently it's 20 cents in US dollars that we are paying for 1 million requests processed by the Lambda. There is also a free tier available. If you are interested in AWS and the pricing, that's whole another topic. But basically, we are paying for incoming events that are invoking our source code on demand, and we are paying for the build time, so how long our code run on the infrastructure. It means also that we need to predefine how much memory it will use, and that's our current top and limit for our functions to run. And also, we are bucketed by 100 milliseconds on the Lambda. So it means that if our code run 120 milliseconds, we will pay for 200. Then price for gigabyte a second, that's the unit made up by the AWS, because you are declaring how much megabytes you will use and how long the function will run. This price is basically multiplied by amount of gigabytes and amount of seconds that you spend on computing. And for that particular request, a single request, you will pay 1.7 microdollars, which is really small amount, but it can add up. We will return to that point later. We talked about pricing. We talked about what is serverless. I would like to talk why we should bother with the serverless. And everything that I wanted to say about it is basically stored in that research paper. Robert Chatley and Gojko Ajit did an amazing job and prepared very detailed research how serverless computing will economically and architecturally impact creating of the software. If someone does not like research papers, I strongly recommend watching Gojko Ajit's talk from Go to 2017. It's brilliant and it covers everything in that paper. Paper itself has three main parts: cost effectiveness, architectural impact, and operational factor, which is a little bit skipped in the title, but it's very important in my opinion. Let's go through the paper briefly and cover those three pillars. First of all, we've got cost effectiveness and how the pricing affects everything here. They did the research based on the comparison of serverless platforms like Lambda, platform as a service solutions like Heroku or App Engine, and infrastructure as a service, which is AWS EC2 in this case. They compared billable units, unit costs, and failover costs that are basically included for the serverless, which is pretty interesting, and we will return to that. And they also covered everything in reference to the Lambda, which is half gig of memory. The failover costs are pretty interesting because if you will consider either platform as a service solutions or infrastructure as a service solutions, you need to multiply by 100% your costs if you would like to be highly available. So if you have one machine running and you want to be highly available, you need to put another one and pay for that another one as well. When it comes to serverless, everything is covered for you because the provider will cover up the high availability stuff and also the scaling up and scaling down. That is very, very interesting. Another pillar is related with the architecture, and the second most important area in this paper is covered and explained very detailed way by this quote. And if you squint, you will see a definition of microservices. At least I am seeing it. They are talking about breaking up the monolith into small functions or services in order to be independently scalable. You can split the team, you can do things in parallel, and basically you are isolated from each other. Is the serverless answer to the microservices problems and hell? I don't think so, at least not exactly in 100%, but it's very interesting that we are choosing the same words and choosing the same arguments over and over again and want to split the monolith into something smaller, something more manageable. And last but not least, I would like to emphasize the operational factor and operational costs. And as I said, this area is not covered by the paper, but it's very important and can be summed up with this one particular quote. They did estimate and actually introduced Lambda to their product, and they reduced the operational cost by 95%. And they supported by the numbers, they supported that number by the evidence and measurements and compared between infrastructure as a service solutions and platform as a service solutions. This 95% is in reference to the infrastructure as a service, of course, but it's pretty significant improvement when it comes to comparison of those costs. I encourage you to look into the paper for more details about it. But you may say that it will be just one paper, and you are right. We shouldn't judge the book by the cover, and we should deeply investigate as engineers what are the pros and cons. Thankfully, I can support the paper with the work and other case studies that are done by such companies like EA, Coca-Cola, Expedia, or smaller like MindMap, CloudGuru, or Droplr. Very interesting thing is that all those companies are using the serverless framework, and I also use that framework in order to support my measurements and my evidences. What is really cool in that list and those companies is the fully serverless massive online course platform that is prepared by CloudGuru, which is really interesting and very, very good service. Knowing what is serverless and why we should bother by the serverless, let's talk about how. So what technology is available there and how I approach the problem of the functional programming languages there. So I started my work on that topic with listing all available functional programming languages. In that case, a functional programming language for me is that one that forces me to use a functional paradigm. So there is no language which is multi-paradigm here besides Scala. But I didn't cover the C++, the C, or JavaScript. Everyone is claiming that you can do a functional and program in a functional way in those languages. Of course you can, with some drawbacks and problems. That's true. F# is also multi-paradigm, you're right. But still, F# and Scala are pretty functional in the nature anyway. So I listed those languages, and then I looked what is available on the cloud provider space. And it turned out that I have no big choice, because it is also limited by the platforms and the runtimes. And that's the first thing that I would like to emphasize when it comes to serverless and giving back and trade-offs. So if we would like to deploy our code and we would like to use any not supported language or not supported runtime, we are pretty much out of luck. We need to be aware of the fact that cloud providers are limiting our choice when it comes to programming languages and runtimes. What is even more funny here is that it is only one runtime that is fully functional in the nature, and that's not JS and that's not Java as well. Only .NET is fully functional in its nature, and I'm claiming that because only the .NET does not have problems with tail-call optimization, which is really important for functional programming. So we have limited choice, we don't have functional runtimes. Why we should bother with the functional languages? I think that there is a added value when it comes to functional programming, and that's why I still strive and still try to embrace that. But we can also cheat, as we always do as programmers or computer scientists. There's one way to actually execute any kind of executable which is compiled into Linux platform with serverless. And you can basically create a small snippet in Node.js or Python which will execute that binary. You will just compile a binary to the Linux platform, attach it in the package, and basically invoke that with the process or any other API that supports spawning new process. That has some drawbacks because you need to maintain the binary, You need to compile it to the Linux platform. You don't know anything about the runtime you will run because you don't have any knowledge about that. It's a hack, basically, but we can do it. I use that hack in order to support Haskell. And that is a fully compiled list that I tried. I removed Elm from here because I believe that Elm is a fully functional programming language, but with the tremendous support only from the front end. And there's no way to actually embrace their philosophy on the back end, so I need to skip it. But we have Buckle script, Pure script, Clojure script in our research. There's Scala and Clojure on the JVM. Those languages run on Node.js. There's one on .NET platform, which is F#. And last but not least, we will have Haskell, which is basically using that hack that I mentioned, the shim. Funny thing about the shim is that in most cases, that was the default way of supporting Go and Golang before AWS, for example, supported that on their platform. And they are doing this way for years. I also skipped my two beloved languages, Erlang and Elixir, because there is no point of actually embracing such huge virtual machine and trying to invoke it as a hack here. And in case of Haskell, I can compile it to a little bit more over half a meg binary. With Erlang and Elixir languages, I have basically 30 megabyte package, which is just a virtual machine, which will be spawned by the Node.js process. That sounds insane. So let's talk about measurements and how I approach the comparison between those platforms and languages. First of all, I prepared the two endpoints. One is basically an echo, so everything that comes in comes out. Then I prepared very naive implementation of prime number generator with an algorithm of sieve of Eratosthenes. And then I chose to compare those four measurements, those four KPIs between those languages. So first one is the package size, because it also matters on the serverless platforms, because we've got limits around that too. Then I chose to compare memory usage and memory footprint, execution time, and startup time. When it comes to those two, I would like to emphasize that I'm not measuring which language is the best one, the most efficient one, or the best optimized. I'm comparing here the predictability, because we will be built on top of those two values, the memory usage and the execution time. So the more predictable the runtime is, the less we will pay. I'm not interested in speeding up everything and having the best or the fastest language. I'm interested in the most predictable one. And last but not least, startup time, which is pretty painful and pretty problematic. There is something called cold start. If you don't have any infrastructure running on your serverless platform, for example, after deployment, then provider needs to lazily spawn up your containers and everything below that. And that means that you can wait with the first requests that are hitting that cold infrastructure for a couple of seconds, even when it comes to different runtimes. So there is a very problematic parameter called cold start, which affects your deployments and affects your APIs that you are building with serverless. And we will cover that as well. So going through these scenarios and measurements, let's start with the package size, because that's the easiest way to compare. First of all, the Haskell one is the smallest. It should be visible, but it's not, because it's gray, unfortunately. I can see it on my side, on my slides. But the Haskell one is the smallest one. As I said, it's a cheat, but basically it means that you can also sometimes use it with success. Then we have very big Clojure and Scala packages. Buckle script is also really, really big. I'm really surprised by the package size of the F#. And to be honest, not considering the Node.js runtime or the hack, this one is pretty interesting finding. And I added also an information about Clojure script without no optimization. And I don't want to bash on Clojure script in that space, but I would like to emphasize one thing. I deliberately disabled optimizations for one of the runtimes and one of the languages, and it turned out that my package blown up into 18 megabytes in comparison to, for example, 2 megabytes here. That's a lot of memory, that's a lot of size, and if you don't know your tools or you are not aware of the all tweaks that are available in your build tools, you are basically wasting your resources and money, and you can actually have such big and massive explosion in the package size. So you need to know your tool chain. But one thing to emphasize, I don't want to bash on ClojureScript especially. It will affect everything else as well if you don't know what to do. Next one is about memory usage. So this is also pretty interesting because as I said, I want to have the most predictable one, not the least available footprint. And if you will compare those things, you will see that F# is pretty consistent, under 100 megabytes. And there are a couple of languages that are misbehaving, like Scala or, for example, problems with Clojure. I'm not saying that it's a problem with the virtual machine or with the language itself. It's more like deciding and seeing that on the default settings of the virtual machine, we are observing such things. One thing to emphasize is that on the X, we've got the number of primes that we are generating. On the Y-axis, we've got the memory usage. Here we've got the limit. No one hit the limit, thankfully, but as you see on the top, on the most, the biggest input size, we are basically really close to the memory limit as well. For me, winner for this round is either F# or again our hack related with Haskell. Node.js solutions are also pretty good. They are not so predictable, in my opinion, as the F#, unfortunately. Next scenario, execution time, and this was pretty interesting. I skipped the first bits because there was nothing interesting there. Everything started and worked below 1 second. And then after bigger input sizes, we observed very strange things like Scala blowing up or Clojure blowing up or even ClojureScript blowing up sometimes. Again, F# was pretty consistent under 1 second. And even Haskell sometimes blow up as well. So is it a problem with the language or runtime? I don't think so. I will say that it's a rather problem with default settings or some decisions that are made by the language or library creators. So Rich Hickey, author of the Clojure, did an amazing presentation on ClojureConch about why he created and developed the Clojure in such way in order to support something he called a situated program. A situated program for him is a program that actually starts up, it's every single bit of memory that is available and stays there as long as it can. And maybe that's not the case for the serverless computing. Maybe there is no need to actually fitting that particular language into that niche. So context is also important. Another thing is that there is no point for optimizing and being as fast as we can, because remember that we are built by the buckets. So if we are below 100 milliseconds, there is no point going even more than 30 or 50 milliseconds, because we will be built anyway for 100 milliseconds. But if we're a little bit above 100 milliseconds, then there's some need for optimization because we can actually pay less for that. Another thing really important here is that for those languages like Scala, Clojure, F# with very big and massive virtual machines that are doing a lot of optimizations underneath, we are not leveraging fully those virtual machines on the serverless computing, because those virtual machines are running really quickly and they are close up and tear down. And it means that, for example, our just-in-time compilation for Scala or F#, or any fancy garbage collection algorithms that are not stopping, they are not used here. And that's not the problem, but rather context again of the serverless computing that we need to be aware of. And last but not least, the startup time, the cold start that I mentioned. And that is pretty significant and problematic for those languages with big virtual machines. On the default settings, those virtual machines are basically losing with the Node.js and our hack. And that's because they need to start up, they need to load everything else, they need to load garbage collection algorithms, class loader will spend some time, and so on and so on. For Node.js, cold start was always below 1 second. And I'm not doing here a single run, but 20 runs for each platform and doing the average. Another thing worth noting, though, are those two articles below. So how long does AWS keep your idle functions, and how you can deal with the cold start in serverless world? That is pretty important thing to consider if you are deploying into serverless computing, because after every single deploy you will face this problem, because your infrastructure is not warmed up and you need to either warm up it artificially and switch the traffic, or you need to use those platforms that are having low cold start time. And when it comes to any guarantees how long your provider will stay and have those warm infra for you, you don't have any. You need to guess, or you need to do this by the experience. And those guys actually did tests for AWS, and it turned out that depending on how much memory you will allocate for the Lambda, it will be either from 15 minutes till 30 minutes, and that's the idle time. So it means that for 15 minutes there can be no requests, and after that AWS will tear down your infrastructure and you will deal with the cold start again. We talked about platform capabilities, performance, and so on, but there's one thing that is screaming out from the serverless, which is dealing with the constraints. I said that we are having less operational complexity, but we are giving up something in exchange. And those things that we are giving up is either language or support for a particular platform, but also a lack of knowledge how containers are reused, as I mentioned in the cold start examples. Serverless is also a very novel and new approach, and that requires new paths, new tools, new services available. For example, debugging in AWS was really hard. You were able to only do log files. Nowadays, they introduced a service called X-Ray, which is available for distributed tracing, and you can do distributed tracing. Also, logging and stuff like monitoring is really tricky if you are not using the defaults that are provided by your provider. You've got limits everywhere, and I said that about execution time, memory usage, but you've got also limits about concurrency, amount of network throughput. You've got limits about package size. 15 megabytes is the top package size for the AWS Lambda that you can have. If you are doing or using Java, sometimes you need to do a slicing and dicing in order to thin these jars that you are deploying. Additional thing, provider limitations. And this is very painful because you are on your own with the provider you choose. That is very problematic if you are, for example, relying for support for particular runtime. AWS introduced .NET Core 2.0 at the beginning of this year, but .NET Core 2.0 was released in, I believe, June 2017. So they have half of the year lag when it comes to releasing that new feature. And you can only complain about that and do the support cases and wait for them. And you have no other options to do. Virtual machine optimizations are required from the get-go, and I mentioned that when it comes to the cold start, and this is very, very good article summarizing, for example, the work you have to do for JVM, any other language like Java, Clojure, Scala. There is a set of the switches that you need to disable in order to have smaller cold start. But even with those switches, the cold start is more painful than for Node.js. And last but not least, beware the toolchain. You need to be aware of everything. It's related with the previous one, but I would like to stress out the situation with the optimizations and knowing how to build your software properly. So, summing up, a final conclusion and call to action for us is that we can do better as a community, especially if we are dealing with serverless. But the winner for me and the sane default will be either F# on Azure or F# on AWS, assuming that you have access to .NET Core 2.0, because otherwise there is no point of doing F#. More than that, I think that tooling still needs improvement. And what I mean is that you can also have a better tooling on the client and user client space, but also on the provider space. By provider space, I mean support for runtime, support for other platforms, and other stuff like that. Or maybe even putting your own containers in exchange for something. But also context is the king. I think that using serverless blindly will introduce more problems than solutions. And if you will do this wrong and you will forget about evaluating your critical thinking, you will basically have a lot of more problems. Do not try and force to use serverless everywhere. Evaluate everything before. That's all what I have for you. If you have any questions, I would like to address them. Thank you for your attention and thank you for being here. Any questions? If someone is interested, everything is gathered here under this link in our repository. Here we have example scripts and implementations that I did. I don't see any questions on the slide, or at least I need to switch. So are there any other questions from the audience? Yeah. You were first. Sir, you were first.
Yeah, okay, I have two questions. I've never done any of these things before. I've never touched AWS or Azure or DevOps or anything like that before. So my first question is, this is all related to the, let's say, business logic of the backend, right?
Yeah, exactly.
So you still need somewhere to store state, which is pretty much the database.
That's right.
Okay, then I get it right. So do you have any percentages in general, or are there any studies that don't only compare
the stateless?
Exactly, like the stateless part against the stateless part, but also show the percentage of how much a database is touched and how much you have to pay for that and for the storage and so on, in comparison, because if this business logic ends up being negligible, optimizing it by 500 times is still.
That's true. That's true. That's a very good question, and actually, I would like to address it on two phases. So first of all, you ask about the studies. Definitely, the study that I mentioned, the research paper, they did their improvements on a tool called MindMap, which is basically an online mind mapping tool, and they have state, and also they moved everything to DynamoDB, which is a serverless. They are claiming that there's a serverless database, no SQL database available on AWS. So they did also those comparisons in their paper. And regarding your question about the stateless versus stateful, and if the business logic is negligible, I definitely agree. That's what I said, that the context is the king. So if you will apply this blindly and you would like to use the serverless because it's hype or it's modest, probably that's the wrong way to go. Any other question?
I switched to the...
Okay. So someone asked about package sizes. Which runtimes are included in the packages and which are hosted on the provider .NET JVM? Are the Haskell binaries stripped? Very good question. So all runtimes are provided by the platform. So in those packages, the jar file does not contain the JVM. We have only the jar files. The same goes for the Node.js, the same goes for the .NET. Regarding Haskell binaries, of course they are stripped. That was a little bit of cheating, but that solution was a hack itself and cheating. Have you?
Sorry,
Yeah?
I was the one that asked this question, but so the Haskell binary contains the runtime. It's statically linked to it.
Exactly. So it contains the runtime, but Haskell compiler does very aggressive optimization of not used code, and it can be stripped a lot.
Sure, yeah, absolutely. But in that case, then, like, you're comparing one language with its runtime included,
Exactly.
and the other packages without runtime.
Exactly.
For example, F# does not contain the .NET runtime.
That's true. That's true.
Okay.
That's true. But still, that was a smaller package at the end, the Haskell one.
Yeah, I'm very impressed by that. Actually, my idea was complete opposite. I expected Haskell to be on all measurements more on the right.
I started with the same assumption, and then I investigate. Maybe there's something wrong with the build chain and so on and so on. And there I read about those optimizations. That is pretty impressive work. Have you tried ahead of time compilation with Graal, JVM, and JLink to reduce the cold start? No, I didn't myself, but the article actually recommends Graal and JLink to reduce the cold start. Still, you are slower than the Node.js. So they couldn't make the cold start smaller for Java, less than 1.5 seconds, if I recall correctly. You can refer the article. They are either recommending switches to the JVM, XMX, a lot of the witchcraft with the XMX switches, or ahead of time compilation. Any other questions?
So to continue the topic of cold start, can I schedule a requirement of the higher load for the specific time in AWS or any other cloud?
So as far as I know, there's no way to schedule such thing on AWS. People are dealing with that in a different way. They are actually deploying new version of the Lambda. They are covering it with the API gateway or any other gateway, load balancer like stuff. And they are trying to warm up and then switch the traffic. So basically they are doing warm-ups on their own.
I didn't understand. So basically, when it comes to deployment, they need to deal with the zero downtime of their own. So like
exactly
from one
to
another.
Yeah.
So yeah.
There is no way to actually schedule that upfront with the AWS team right now. Maybe there will something change in the future.
Okay, so that was also a question regarding the use of the serverless world and the storage and other things. So did you see the purely serverless system? Is that possible to?
The stateless one?
Serverless completely.
Okay. Yeah, so for example, this mind maps use case was purely serverless. As I said, for storage they use DynamoDB, and AWS is claiming that it's serverless solution. So you are paying, the better write capabilities and read capabilities you have. So it's actually a software as a service solution, which is fully serverless in their definition. Yep.
And how many issues you had when the cloud provider updates their environment?
That's a very good question. So in my test, I have none because it was on a small scale. But you are in a full control where you deploy. So there's no way to actually. You are saying that you are deploying on JDK 8, for example, or Node.js in particular version, and they won't update it behind the scenes for you. They can introduce new container with newer version of Node, but you need to switch it and explicitly say that you want this new version.
Yeah, that was a good question. So all in all, we are talking about the functional languages. So yeah, for example, in the traditional bare metal machine, I can set up Erlang and connect to it on production in case of any issues. What the possibilities are in serverless work? How I can do the debugging?
Yeah, so in most cases you have log files and any service that is doing log files for you on the platform, but also there are tracing frameworks built into the platform. AWS has the service called X-Ray, and if you will include the SDK for the X-Ray, you can actually do the live tracing and investigate the capabilities and what exactly happens when you are executing the code. There are also other ways that you can connect from other services like Cloud9 to your Lambda and enable debugging, but they are more related with the particular platforms. So you are basically on the provider's fate. Okay, I believe that's all. Thank you very much.